Good morning, everyone. Thank you for being here. Thank you so much. I'll just quickly start off today's session with a recap of what we discussed yesterday, and then we'll talk about what we're going to discuss today. But before that, I just wanted to get a sense about what was your experience from yesterday's session. Be as candid as possible, be as honest as possible. Just let me know what else would you want to look into or would you want to explore as part of these sessions today. Anyone? Honest impressions. Okay. Yeah, please go.
So, yesterday I was asking
Okay.
So, we have your own project,
Yeah.
it's connected to what we have done this week.
Right. Yes. Yeah. Yes. Yeah. Right. Sure. So something that I've already worked on, different kinds of projects, is something that you would want me to share. Okay. Point taken. Any other point? Okay, so there is a lot of ground to cover today. So I won't waste any more time and let's start with the session. So we were discussing about different kinds of research, different types of research yesterday. The three are mentioned on the presentation as well on your screen. These three terms are very, very simple, and it is basically what the term suggests. So first one is causal. So we talked about a lot of arrows yesterday when we were drawing the theory of change, right? And we called them causal pathways. So by causal I mean if then. So if this happens, then this would happen, right? And this is exactly what we are trying to do in evaluations, right? So if you provide an intervention, there would be certain change in the key outcome indicator or in the impact indicator, right? So if there is an if then sort of a relationship, if then relationship. So this is basically where all kinds of evaluations will fall under. Okay. There is one more important point under causal research, is that it starts with a hypothesis. What is a hypothesis? An assumption. Okay. So an hypothesis would be that yes, my project has worked. The alternate hypothesis would be the project has not worked. Right? Hypothesis, we are very clear. These kinds of causal research actually starts with a hypothesis. And this evaluation is basically conducted to test the hypothesis, whether it holds true or not. Just in case. Again, going back to 11th standard. Right? Do you remember anything of this sort? These were two statements that were written. So as evaluators, we are very, very pessimistic people. So this is the null hypothesis. This is something that we call null hypothesis. So by mu naught is what we call it. Okay. This statement always says that there has been no change because of the intervention. The null hypothesis says that there has been no change in the outcome indicator because of the intervention. No change. The alternative hypothesis says there has been a change. Right? Now let's think from the implementer's point of view. which of these two statements would better suit the implementer? The null hypothesis or the alternate hypothesis? Alternate hypothesis, right? Very simple. So when we start off with the evaluation, we say that there has been no change. That is the hypothesis that we are trying to test. And for the implementer, you would always want to reject the null hypothesis. So the moment we reject the null hypothesis, the alternative hypothesis becomes true. Simple. So for any evaluation, we start with a null hypothesis. For example, if again we are taking the income example, right? So let's assume that the key outcome indicator was 20% of the households have a mean annual income change of 30% or more, right? The null hypothesis in that case would be that 20% of the households did not have an income change of 30% or more. That is the null hypothesis. And as implementers, you would want to negate the null hypothesis. So that basically says that the project has been successful and there has been a change. Right? Okay. So an evaluation always starts with a hypothesis in place. Any questions here? You might ask, how do we come up with a hypothesis? Is it only imaginary? Or is it backed by some data? So many of the topics that we actually work with in the social development space, there's always been a lot of research that is already conducted by some other organization, some other researcher, some other evaluator. Okay, so in most cases, you would find a lot of literature based on which you can actually substantiate or come up with your hypothesis. Right? You can cite a lot of literature, you can do a very good literature review and say that so many papers or so many books have actually said that this happens. Right? So based on all this literature, I am stating my null hypothesis that there has been no change in the intervention, and I'm assuming by the end of the evaluation, I would see some change in my intervention. Right? It can be based on, it is good if it is based on some secondary data or literature review. If it is not, then also it is fine. Okay, so it starts with a hypothesis. In terms of descriptors, what happens in descriptors? Say if I want to say, okay, how many of us found yesterday's session boring? Right? So it is a descriptive study. What are descriptors? Every time you hear about descriptors, measures of central tendency is what should pop up in our heads. You remember measures of central tendency? We learned that in 9th standard long back, many years ago, right? Measures of central tendency. Again, a very fancy term. Very fancy term. It basically speaks about three things: means, median, mode. Remember these three terms? Means we are all familiar with, right? We are talking about arithmetic means, not geometric mean, right? We are talking about simple arithmetic mean here. Median. Anyone remembers what a median is? Okay. What is the median of these values? How many say 6? How did we arrive at 6 here? We actually put these numbers in ascending or descending order, whichever you like. So 3, 5, 6, 7, 10 in the ascending order. The descending order would be 10, 7, 6, 5, 3. If I do that, there's this one number which is equidistant from both ends. 6 is equidistant from here, 6 is equidistant from here, 6 is equidistant from here, 6 is equidistant from here. So this is the median value. Right? This is in case when you have odd numbers. 3, 5, 6, 7, 10. 5 numbers we have here, right? So it's an odd number. So this becomes the number at the center actually becomes a median value. Okay. Let's assume if it were even number. Let's say 10 wasn't there at all. What is our median value then? 5 plus 6 by 2. So in case of even numbers, these two are sitting right in the middle of everything. So we simply get a mean of these two. 11 by 2, 5.5. Okay. What is the mode? Let's say 10 was also there. What is the mode? What is the mode? The mode is, how many of us would say the mode is 0? Or can the mean mode not be calculated at all here? Okay, so tell me the mode here. 10, right? So basically the number that repeats the most becomes the mode, right? Why do we need these three? Obviously they are measures of the central tendency. We are basically looking at the value in the middle. Why do we want to see the value in the middle? Why is it so important that we were forced to read this in 8th standard, 9th standard? Or maybe even earlier than that? We're talking about only 5 numbers or 6 numbers here, right? When we do a survey, the numbers could get as high as 1,000, 10,000, 1 lakh, 10 lakhs, 1 crore, 10 crores, 100 crores, right? We are not concerned about all those numbers, right? We need to make sense of that data. How do we make sense of that data? If I can look at one particular point that gives me a sense of what my overall population is like, right? So if I have numbers from 1 to 1,000, I'm not concerned about all those numbers. There might be 1,000 numbers, there might be crores of numbers. I'm concerned about to interpret or to make some analysis. I have to be concerned about that one point which basically tells me the story about the entire population. Right? So that's why we're talking about means, median, mode. Let's say, all of us are earning different kinds of incomes. All of us come from different financial backgrounds. We are working in different departments, we are working in different organizations, right? If I were to look into the incomes of all the members here, that might vary from any number to any number. And I will not be able to come up with any interpretation for this entire group that is sitting in this room. How about I simply talk about a mean of the total salaries of all the members who are sitting here? That might give me a story. That might tell me a story that the mean income of all the members sitting here is say 1 lakh rupees. Okay. So if I were to develop some policy based on it, maybe say all the members who are earning less than 2 lakh rupees should avail a particular scheme or should be the beneficiaries of a particular scheme. So then we become beneficiaries of that scheme, right? So that's why mean, median and mode are important. That's all. Okay. These are measures of central tendency. Okay. Right. So descriptives, as the name suggests, every time you think of descriptives, think about measures of central tendencies. Basically, what you're trying to do here is just look into means, medians, mode. This could be and also, this could be or also. Right? Does not mean that you will not be looking into mean, median, mode in causal research or exploratory research. You will be looking into mean, median, mode for all these kinds of research. But this is a very, very simple sort of a research. Right? In which you are not trying to detect any change. In causal, we were always trying to get an if-then sort of a relationship. Right? One of the examples for causal research would be how many members sitting in this group have had an income change of 20% in the last 5 years. We're talking about a change. So that becomes a causal research. How many people in this room are earning more than 1 lakh rupees per month? That becomes a descriptive. Simple, right? It becomes a descriptive research. Okay. How many members in this room are likely to become a football player in the next 5 years? Now, some of us are not even trying. Okay. So that becomes an exploratory study. Right? Is there water on Mars? What kind of a study is it? Exploratory. Why is it an exploratory study? Obviously, when you go to Mars, you will also try and understand how much water is there, in which areas is the water there, right? In which form is water there? Is it frozen water, right? All those kinds of things you would do. There will be a lot of descriptive analysis later, but the basic question that you're looking at, the key research question that you're looking at, is exploratory in nature. You don't have any study to back it up. You don't have any data, any literature to back it up. There have been no studies done on it so far. You are getting into uncharted territories and trying to get some evidence out of it. Is there any other planet in other universes or other galaxies comparable to Earth? Exploratory. Right? So we got the difference, right? We get the gist. What are these 3 different kinds of research? Okay, so because we've got the gist here, we move to the next point. Can anyone, is everyone able to look at it or read it? Everyone, towards the end? Is it visible? No? Okay, no worries, no worries. So for this session, for today's session, we will be focusing on causal research largely, because we're talking about evaluations, right? We're talking about kinds of studies in which there is a change. We're talking about studies in which there will be an if-then sort of a relationship. We're talking about studies which will have a hypothesis in place. The reason why we're talking about hypothesis is because we are trying to evaluate certain programs, schemes, missions, right? And they've all started with some sort of an assumption. They are all working towards some sort of an impact indicator, an outcome indicator, right? So there is always some hypothesis behind the kind of work that we already do. So in terms of research designs, you would see for exploratory research, there will be focus group discussions. Secondary research, and largely qualitative research or expert surveys. So this is for exploratory. These are some of the kinds of designs that you will use. What are focus group discussions? You would have seen researchers or evaluators sitting in a group of people, getting so many respondents in one place, and then asking them questions. Then the participants in that particular conversation will have a discussion amongst themselves. Right? It's more like a TV debate, but not exactly like one. Okay. So there is a moderator. So the evaluator, the researcher actually plays the role of a moderator. Say, if I would want to understand why are certain things working in your household. So for example, I want to understand what are the benefits that you see in using clean cooking gas or liquefied petroleum gas, LPG cylinders, over the traditional wood or charcoal that you burn. Right? So I would get all the women in one group, let's say 15-20 women in one group, right? And then I'll start the discussion. I'll give them this topic, and then one of the women might say, okay, I don't find this useful at all because of XYZ reasons. The other women might refute that argument. She might have different opinions. She might say, no, I think LPG has made my life much easier. I simply have to get a refill, and it doesn't have any smoke at all. It helps me a great deal as far as my health is concerned, right? And then other women might also pitch in, and they might have their own sets of points and discussions, and it will be mostly like in a form of a discussion. Secondary research and qualitative research is something that we already know, so we will not focus too much on it. If you come to the other descriptive sort of a design, descriptives, it has two kinds of research. Have you heard of these terms, cross-sectional, longitudinal? Any of us? Okay, so cross-sectional is like you're going for a survey and you completed it in one go. Okay, so in one particular time frame, you're going to visit certain households and complete that survey. So that is cross-section study. Right? So there is one cross-section, right? One time frame. Let's say you go to the same set of people every year, or say after 3 years. What are we doing? This is basically longitudinal study. So longitudinal study would mean that you're going to same set of people at two different time periods, T0, T1. Right? You can go to the same set of people for 15 years, right? Every year for the next 15 years also. It could be every month, it could be every week. You decide the frequency, right? Now, so even this longitudinal study has majorly two kinds of studies: panel, cohort. Many people in the sector would actually confuse these two terms. They would use it interchangeably. Okay? But please don't get confused. I'll make it very, very clear. If you're going to the same set of people, say 1000 was my sample. I went ahead with a random sampling. I sampled 1000 respondents at the baseline, 1000 respondents at the end line. Right? I'm going to the same set of people over a period of time, asking them the same questions. What does it become? It is a panel study. Right? What I did a random sampling. I came up with 1000 respondents. I interviewed them at the baseline. I went to the same 1000 respondents at the end line, asked them the same set of questions. It is a panel study. Okay? Cohort study is slightly different from a panel study. There's a very, very thin line. So, for example, out of these 1,000 people, say I was conducting a study and I just randomly sampled 1,000 respondents. Okay. Now, after conducting the study, I realized that 200 of these 1,000 people had tuberculosis. Okay, I realized that 200 out of these 1,000 people had tuberculosis, and I'm conducting a research or an evaluation on tuberculosis. So I was actually interested in interviewing tuberculosis patients, but obviously because I could not get the list of tuberculosis patients directly, I went ahead randomly sampling 1,000 patients here, out of which 200 were actually found to be tuberculosis patients. And if I interview the same people in a different time frame, these 200 people at a different time frame, then there is a cohort of 200 tuberculosis patients. What is the difference between panel and cohort? A cohort is a set of respondents, or a cohort is a set of people who share some similar characteristics. This is the only major difference between a cohort and a panel study. Panel study may comprise people who may or may not share some similar characteristics. It could be just a random sample at the baseline, and then you've gone ahead interviewing the same set of people at the end line or midline or whenever you like. Right? But in cohort, they share a similar characteristic. Here in this case, what is the similar characteristic? Tuberculosis is what binds them together or makes them similar. Right? Great. So that is very, very clear. Cross-sectional study. Right. So there are two kinds of cross-sectional studies also. Single cross-section, multiple cross-section. Okay. So if you go and conduct the study in one go, right, in one point in time, say I've just randomly sampled 1,000 respondents, I've gone ahead and conducted a survey with them. What is that kind of a study? It's a single cross section, right? Let's say thousand was the sample here. I went to 1,000 people again in the second year. In the third year, I also went to 1,000 people. In the fourth year also, I went to 1,000 people. What is it? Is it a panel or a multiple cross-section study? First of all, let me make it very clear. This is a multiple cross-section study because the sample is the same. But I never said that these are the same 1,000 people that we are interviewing over a period of time. Okay. So what I'm trying to say is that if you interview 1,000 people in one go, it is a single cross-section study. If you interview the same sample, by same sample I mean the numbers, say 1,000 people in year 1, 1,000 people in year 2, 1,000 people in year 3, 1,000 people in year 4, and so on and so forth. But these people may or may not be similar. You've actually gone ahead with a random sampling in year 1, year 2, year 3, year 4, year 5, right? These people may or may not be similar. You have no clue. You've gone ahead with a random sampling in every year. Okay, so this becomes a multiple cross-section study. But had you gone to the same set of people in year 1, 2, 3, 4, 5, then it would have been a panel study. Perfect. And let's say out of these 1,000, 200 people who are earning less than $200, and you wanted to do a different study for them, say in second year, third year, fourth year, fifth year. What kind of a study would that be? Will it be a panel or a cohort? It will be a cohort because they share a similar characteristic. Okay, so we are clear here. Cross-section studies, longitudinal studies, very very simple. Cross-section studies, single cross-section, multiple cross-section, panel studies and cohort studies under longitudinal. Now there is one more study that you can undertake here under longitudinal studies, something called trend. So usually you would have seen a lot of people actually doing some forecasting or trend analysis sort of a thing. So what is happening, you are going to the same set of respondents over a period of time, but maybe you have started with 1000. In the second round, maybe you are left with only 800. In the third round, you are left with 700. In the fourth round, you are left with 600. Right? So the sample size does not actually matter. You're just trying to understand what has been the changes over a period of time. Right? So that is more of a panel study, but with a time component in mind. So that becomes a trend study. Right? Trend study isn't that important, especially the kind of work that we're doing right now. But panel and cohort will be very, very important. Okay, so with this, let's move into the most important component. Right, the last one, which is causal. Causal research, again, of two types. There are many types essentially. Okay, so there are two kinds of designs here. One is experimental design, the other is quasi-experimental design. Okay, under experimental, there are RCTs, there are stepped wedged designs or pipeline designs. Under RCTs, this could be individual or could be cluster RCTs as well. Okay. What is a randomized controlled trial? We discussed it yesterday. What is a randomized controlled trial? The moment we hear about randomized controlled trial, they should be like two groups that emerge in our imagination. One should be treatment groups, the other should be control groups. Treatment groups get the treatment, as the name suggests, and control groups are given placebo or no intervention at all. Right? Experimental design, what we are trying to do, we are basically conducting an experiment. The moment we think of experiment, think of the mice example. Right? So we have a treatment group, a control group. Right? If the intervention is provided randomly to certain set of mice and not to certain set of mice, then it is a randomized controlled trial. Okay. right? Now, what kind of an RCT is it? If we are taking the mice experiment, say out of 20 mice, 10 have been given the treatment, 10 have not been given the treatment, or they have been given the placebo. We are providing the intervention at the individual level. Each mice is getting a treatment. Okay. At the same time, our objective is to ascertain what is the proportion of mice that got treated after vaccination. I'm saying it again. What is the proportion of mice that got treated after the intervention? So what are we talking about? We're talking about individuals. We're talking about the percentage of mice, right? So it becomes an individual randomized controlled trial. What are the others? What is a cluster? It is a group. Another fancy name for a group. It's a cluster, right? So let's assume that there are 10 hospitals and they are all into conducting research and evaluations. They're all coming up with a vaccine, or they are trying to test a vaccine. Okay, they have all participated in one research. Now there are each of these hospitals are basically conducting or maybe keeping or providing different kind of food to their mice and all of that, right? Situation is also different. You are providing treatment to 5 hospitals, to the mice of 5 hospitals, and you are not providing treatment to the mice of the remaining 5 hospitals. What is happening here? The intervention is being provided at the hospital level and not at the mice level. Okay, another example if I can think of. Let's say in the education space, and there are a lot of RCTs that actually happen in the education space because there are a lot of online learning platforms, MOOC materials that you would have seen, right? Especially during COVID, a lot of online learning platforms actually did really well. So they've been testing this model, and what happens is that let's say 5 schools were provided some sort of a technical input or a technical platform, right? And the remaining 5 schools were not provided a technical platform. Okay, and at the end of the year, you just want to understand whether these technical platforms have been able to make some change in the results of the students. Have the percentage of the students gone up because of this intervention, right? So the intervention is being provided at the school level. School is a cluster of students, right? So if the intervention is provided at the cluster level, then it is a cluster randomized controlled trial. Out of 10 schools, I just randomly sample 5 schools, and the children in those 5 schools will be provided the intervention. The remaining 5 schools will either be given a placebo or will not receive any treatment at all, right? So they become the control, and you simply just do a difference between these two at the end of the project and see what has been the change because of the intervention. Simple RCT, right? So that becomes a cluster randomized controlled trial. We got the difference, right? Any confusion till now? Any confusion till now? Okay. So RCTs are simple. RCTs are very simple, right? You've got the gist. Okay. Now what are stepwise designs? You won't find this mice example happening in real life, right? It doesn't happen that frequently. So if we look into all kinds of programs, can we think of any program right here, right now? Let's talk about Swachh Bharat Mission. Or let's talk about SRLMs, State Rural Livelihood Missions. What happened in SRLMs? Did the entire state of Meghalaya start the intervention in one go? That cannot happen, right? Might have started first in certain districts. And why would it have started in certain districts? The implementation team might have felt that certain districts are better placed to receive the intervention, or they are better equipped to receive the intervention, right? So they started the intervention, say, in 2 districts first, and maybe after a year they started the intervention in the other 2 districts also, and maybe they started with 3 districts in the last year. So what are we talking about? We are talking about a phase-wise implementation. Will an RCT help you in a phase-wise implementation? Here the process is very simple. You provide the intervention in one go. In RCTs, even if you talk about individual RCTs or CRCTs or cluster randomized controlled trials, you are providing the intervention in one go. You get the treatment, some people don't get the treatment, you find the difference, that's all. Right? But what happens if the intervention is provided in a phased manner? That is when we use step wedge designs or pipeline designs. So by pipeline, what we are basically saying is it's a phase-wise implementation. It is a phase-wise implementation. I'll just show you something. Okay, are we all able to see it here? Okay. So let's say these 4 clusters comprise our project area or our treatment area. Okay. We conduct a study. If you can see, this is pre-trial, pre-experiment, pre-intervention kind of situation. It is the baseline. As I said, people in the sector actually like using a lot of different terms at different points in time. Okay, so some people would call it pre-trial, some people would call it baseline, some people would call it pre-intervention, right? Pre-program. All of those kinds of things mean the same thing. Okay, so here what you did, you conducted a baseline for all these 4 clusters, cluster 1, 2, 3, 4. Right? Simple. Then in phase 1, cluster 1 receives the intervention. Blue is the intervention. Okay, so the program has started in cluster 1 in phase 1. Okay, the remaining clusters, cluster 2, 3, 4 have not received the intervention. Simple. In phase 2, clusters 1 and 2 have received the intervention, the remaining 2 have not received the intervention. Similarly, in phase 3, clusters 1, 2, 3 have received the intervention, 4th one has not, and then there is a 4th phase in which all the areas receive the intervention. Everything is in blue, everything is changed from orange to blue. Okay. This is the baseline, this is the end line. If I were to understand the overall differences between the baseline and the end line, can I simply subtract the end line estimates with the baseline estimates and get the project impact? I can do that, right? I can do that, but that might not give me a very, very true sort of a picture, because there has been a difference in the exposure to the intervention. There has been a difference in the time frame of the intervention. So if you see, cluster 1 has received the intervention for the maximum year. Let's say these phases are first year, second year, third year, fourth year. Cluster 1 has received the intervention for 4 years. Cluster 2 has received the intervention for 3 years. Cluster 3 has received it for 2 years. And cluster 4 has received it for 1 year only. It might have an impact in their outcome indicator also. So, logically, if we go by simple logic, cluster 1 would have performed the best. Cluster 2 might have performed not as good as 1, but better than cluster 3 and 4. Similarly, cluster 3 would have performed better than cluster 4, but not good as 1 or 2. And cluster 4 would have performed the worst. Right? The reason why we can say that is because there is a difference in the exposure to the intervention. There is a difference in the years of implementation that each of these clusters are receiving. Okay? So that also needs to be factored in. Also, if you can see, the orange ones are mentioned as control condition and the blue ones are mentioned as experimental conditions. What does this mean? The baseline, nobody has gotten an intervention. The end line, everyone has got an intervention. In this year or in this phase, only cluster 1 has received the intervention. So it becomes the treatment. And the remaining 3 become the control. In this year, the blue ones, cluster 1 and 2 become the treatment. 3 and 4 become the control. 1, 2, 3 become the treatment. 4 becomes the control. And the last one, everything becomes a treatment. So this really helps. Step-based design actually keeps into consideration or takes into consideration the situation happening each year also. So you can conduct an evaluation not once, not just simply doing a baseline and inline difference, but you can do an analysis between these two also every year. You can compare the treatment with the control, you can compare the treatment with the control, you can compare the treatment with the control. All these things taken together are put into the final regression equation. The only difference in all these things being the time variable, the exposure to the intervention. Some areas have received like 4 years of implementation, some have received 3 years of implementation, 2 years of implementation and 1 year of implementation. So the only thing in that regression equation y is equal to mx plus c, right, is the time variable. That is the only difference. Right? Rest everything remains the same. Rest remains the same completely. Okay. So is this relevant? Is this more relevant for the kinds of large scale projects that are undertaken by the government? Because large scale projects cannot be implemented in one go at all, right? There are so many challenges at so many levels. Okay, so usually if you would hear anything about randomized control trials, it will be for large scale projects, it will be a step-based design or a pipeline design, right? In which situations would you actually find an RCT being conducted? One thing is for sure, that RCTs are not conducted at very large levels. That's why we are adopting a different sort of an approach, a step-based or a pipeline approach for large-scale evaluations which are basically implemented in a phase-wise manner. In which situations would an RCT be conducted? Say if you've come up with a very innovative solution, you would first want to test it on like 10 schools, 5 schools, 2 schools, 3 schools. And if that gives you a good evidence that yes, your program is working, in that case you might want to extend it to the entire population or to the entire country, say all the schools in the country. What I'm trying to say here is that RCTs would largely be used for pilot interventions that might be later scaled up if the evidence is positive. Usually smaller interventions. छोटे interventions के लिए use होगा. It will not be used for very large scale interventions in one go. Right? Okay, now let's do a simple, before moving on to quasi-experimental designs, I would request you to just play along with me. How many districts are there in the state of Meghalaya? 12? 12? How many? 12 districts, perfect. 12 districts, okay. So if I were to perform an RCT in the state of Meghalaya, say I want to provide an agricultural intervention that might increase the yield of the produce for the farmers, how would I go about conducting an RCT here in the state of Meghalaya? Anyone? Just take a wild guess. There are no right or wrong answers here. There are multiple ways in which you can conduct an RCT. You start with one district first, okay? The stepwise approach. So what he has assumed is that the intervention might not take place in one go in the entire state of Meghalaya. It might start with one district, then maybe 2 districts, 3 districts, 5 districts, 10 districts, whatever. Right? So he might use a stepwise design in that kind of situation. Fair enough. What are the other ways of conducting an RCT? And assume that the intervention can happen in one go also.
I think it can happen in one go because it can be done individually also.
Right.
So you can, pocket certain blocks.
Right.
Even in many districts.
Yes. So what he's suggesting is that certain districts will be given the treatment and certain districts will not be given the treatment. So out of 12 districts,
maybe all also.
Right. So if we give the intervention to all the districts, then we'll have to come up with quasi-experimental designs. In experimental designs, it has to be very, very clear. Either you provide intervention to half of them. I mean, the numbers could vary also, right? But ideally, it should be like you provide intervention to 6 of them. You don't provide intervention to the remaining 6. So that would be an individual RCT, or would that be a cluster RCT? Would that be an individual RCT or would that be a cluster RCT? Depends on the question that I'm asking. So if I'm asking the question that I need to understand what has been the change in the yield for the farmers, then it is not a cluster randomized control trial. Right? So there is usually a very, very thin line between individual and cluster randomized control trials. Some people say that if you randomize the clusters and not the individuals, then it is a cluster randomized control trial. Some people would say it completely depends on the question that you are asking. So if you are asking that for me to generate estimates at the farmer level and not at the district level, then it is not a cluster randomized control. Then it's an individual randomized control trial. Right? I would still suggest that randomized controlled trials in which the control, if it is a cluster, if it is a district, then it is a cluster randomized control trial. District is a cluster of PT. If we are randomizing the districts, it becomes a CRCT. It becomes a cluster randomized control trial. Simple? Okay. So that is second approach. We've talked about stepwise designs. We've talked about randomizing the districts. What else? How else can I conduct an RCT in the state of Meghalaya? Think out loud. I mean, it could be you have all the resources in the world at your disposal. Okay, so I'll just take you through another example. Let's say you have the list of all the farmers in the state of Meghalaya. Let's say there are 20 lakh farmers in the state of Meghalaya. Okay. Now you have the list of all the farmers. You have their names, you have their contact numbers, you have their address, in which village they are, in which block they are, in which gram panchayat they are, and in which district they are. Right? You have all those details. Can you randomize them? Logically, we can simply randomize them. You have the list of 20 lakh farmers. You can simply go around randomizing them. You get a randomized list. Some say 10 lakh of the farmers can be provided the intervention. The remaining 10 lakh will not be provided the intervention. You can see the difference in their yield towards the end of the project, and that is the project impact. Simple, right? You can also try and pilot this in one district. Okay, let's just randomize the farmers in one district. See what is the change in their yield or incomes, right? If it is a positive change, then obviously it gives you'll be more encouraged to scale it up in the other districts or in similar districts, right? If it works there as well, then you further scale it up to the entire state of Meghalaya, right? So there are different kinds of ways in which you can conduct RCTs in stepwise designs or experimental designs. Any confusion here? Any questions? These are very simple, right? Very simple. Great. There are a few basic criteria that are very, very important for experimental designs. Can you see the screen? What happens in an experimental design, there are 2 to 3 major assumptions that we take. We say that the population that we are surveying or the population that we will interview, even the sample that we interview, will be homogeneous in nature. Remember the mice experiment. Same temperature, same food, same genes, same race, same breed, all of that, right? That is possible in a clinical setup. That is not possible if we are dealing with human subjects. So in the other example that we took about the farmers in the state of Meghalaya, obviously that will not hold true. They'll be coming from so many different tribes. They'll be coming from so many different kinds of social backgrounds. They might come from different kinds of geographies, different kinds of hills, right? Different kinds of vegetation, different kinds of food produce that they are that they're producing, right? So that is not possible in an experimental design. Becomes very, very difficult. We are not a homogeneous group. And the second major requirement is, which is basically the second point, is more important. It has to be a random assignment. We need to provide the intervention randomly to people. Okay. So if you see about what happens in many of the large scale projects or large scale programs, there is no baseline in place. So if you remember when MGNRGS would have started long back, almost like a decade ago, there has been no baseline for it. Nobody knows what was the situation before MGNRGS started. If you talk about SRLMs also, NRLM intervention started in 2011, you don't have a baseline. For many of the big projects, you don't have a baseline, right? Because the focus is also to put more inputs into implementation, right? And that is gradually changing. We are getting the baselines in place and all of that, right? So if we are not introduced at the baseline stage, then the evaluator will not be able to randomly allocate the treatment to certain people. Right? As the treatment has not been randomly allocated, then experimental designs are not possible. That is a basic premise for experimental designs. The word experiment actually comes from randomness. Remember, research designs, the quality of a good research design, it should be free from all kinds of bias, which means that the sample selection should not be purposive. It should be random, right? Randomness is very, very important. But if at the baseline I am not asked about, say, if in the state of Meghalaya, the government thinks that yes, out of the 12 districts, it is good that we start with 6 districts, but I think according to the government, these 6 districts, say district 1, 2, 3, 4, 5, 6, are better placed to receive the intervention right now. Okay, that is a logical call by the government. Obviously, it makes sense, right? To go ahead with intervening those first 6 districts and then moving on to the others. Now, what we have done is that is not a random allocation of treatment. That is not a random assignment of treatment. Okay, so we have purposively selected certain districts and not selected the remaining. Okay, then the experimental designs go for a toss. It will not be possible to go ahead with random assignment in that case. If experimental designs are not possible, then we go to quasi-experimental designs or pseudo-experimental designs. Why do we call them quasi-experimental designs or not experimental designs? Because obviously, there is no random assignment of the treatment in quasi-experimental designs. The state government of Meghalaya has decided that 6 districts will receive the intervention and 6 districts will not receive the intervention. They have taken a logical call, but this is not randomly allocated. These are purposefully selected. So we go ahead with quasi-experimental designs. Okay. Now, what is a DID? In quasi-experimental design, this is the first design that we talk about. What is a DID? Difference in difference. A double difference. Something that we discussed yesterday also. If I conduct a study with say 1,000 respondents in these 6 districts to understand what is the current situation of their produce or the yield at the baseline in the absence of the program, let's say 50% is the yield right now of a certain crop, and in the control areas it is like 40% at the baseline I'm talking about. This is the baseline stage. At the end of the program, I go there and I conduct interviews with another cross section of people. Because of the intervention in the treatment areas, the yield has gone up to 90%. In the comparison area, maybe they are also coming up with certain kinds of solutions, right? So this has increased to 60%, right? The difference between the treatment and the control at the baseline was how much? 10%. So this is D1. D2, 90 minus 60, 30%. What is the DID estimate? D2 minus D1, 20%. This is the net impact of the project. Simple? Very, very simple. Now some people might say, why are we only doing a difference of these two? Why can't we do a difference of these two and then these two and then do a double difference of these two? You can also do that, you will get the same, right? So 90 minus 50 is a 40%. And 60 minus 40 is a 20%. 40 minus 20% is 20%. Value is the same. So either you do a difference between the treatment and the control at the baseline and the end line, or you do a difference between the baseline and the end line for treatment and control, it means the same thing. Right? So this is a DID design. What does a DID design require? It requires at least 2 rounds of data collection. It requires at least a baseline and an end line. You can have many midlines also in between. Let's say you are looking at a 20-year program. Okay, so you can have like midlines, 4 midlines in the middle of the baseline and the end line. It's completely up to the evaluation team and the program team and how much resources you have in place. Right? Okay. This is where it gets interesting. Experimental designs require. So random is something that we've talked about, right? We did not talk about another problem here. We are not mice. We are dealing with human subjects in honor service. They are different people, right? They come from different backgrounds, right? So if you simply do a difference or a double difference of them, okay, I'll cite an example that might really help. Okay, let's say there are 2 groups here. I'm assuming that there were same number of people in this group and this group. There are 2 groups, people sitting on the right, people sitting on the left of me. Okay, and the number of participants were also same. Let's say 10 people were here and 10 people were here, right? Are these 2 groups similar? Say I provide an intervention to them which might increase or improve their learning outcomes. I give a test to both of you at the initial stages, right? And because we are assuming that these 2 groups are similar, the findings or the results will also be similar for both these groups, right? Towards the end line, because I provided an intervention to them, probably their outcome might increase. They might have scored better in the tests. So they've scored at 90% and you've scored at 60%. I simply do a DID and get the impact of my intervention. It was that simple. But my basic assumption that these 2 groups are similar, is that right or wrong? Are these 2 groups similar? These 2 groups are not similar. Right? So, what do I have to do? I need to match the groups. So for user from this group, I'll have to find someone here in this group who shares the closest similarity to you, so that your estimates towards the end of the project, I'll just match with that person from that group. You, ma'am, I'll share your characteristics that I've collected the baseline. I'll share with someone who's the closest match to you from this group. And towards the end line, I'll compare your characteristics with that person. That will give me a good estimate of the project. I'll do it for all the members here in this group and this group, right? And I'll compare the results, and that will be the net impact of my project. Is that okay? Is that a better way to go ahead? Right? So what we usually do, we are simply doing the DID as it is, but we are also doing some sort of a matching. Okay? Now what is matching? As we discussed, for sir, I've collected some information. For this entire group, I've collected some information. Now I'll compare, or based on the data that I've compared to sir, I'll look for some individual who share the closest similarity. Right? And then I compare the results towards the end line. Right? So this is matching. What am I comparing? What are the indicators that I might compare on? Say we are all farmers here. The intervention is on improving the yield or increasing the yield of certain produce. Right? Should I compare sir's yield with someone here? Or should I just compare sir's education qualification, financial background, social background with someone here for the same indicators? There is a term called covariates. What are covariates? What are covariates? These are variables that do not directly impact the outcome indicator but indirectly have an influence on them. Okay? So when you create the theory of change, nowhere in the theory of change you mention in the activities that I'll provide my intervention to people from ST categories who are living in certain geographies under certain temperature. Right, you did not mention all of that in the theory of change. So these kinds of characteristics, which are basically not directly influencing your outcome indicator or impact indicator, but are indirectly contributing to it, are called covariates. So the matching should always be done at the covariates level. So I'll collect this kind of an information from sir and try and match someone here from the group at this stage. So the matching is done using covariates. Now let's take the example of a few covariates. Say if I were to compare villages, if I were to match villages, not individuals but match villages, what would I do? Okay, so this is a primary census abstract data that is coming from Census of India 2011. Right? So there is state name, district code and everything. CD block is community development block, right? Town, villages, ward, election block, level, name, it is whether total, rural, urban, TRU. That is all mentioned here, right? It also talks about number of households, total population, total males, total females, population under 6 years, males under 6 years, females under 6 years, population of SC category, male SCs, female SC category, population ST category, male ST category, female ST category, population literate, male literate, female literate, population illiterate, male illiterate, female illiterate, total working population, right, so on and so forth. Main working population and so many indicators are already mentioned in the census. Marginalized farmers. Now let's say I were to provide intervention to 50 villages and not to the remaining 50 villages. What do I need to do? I'm not going ahead with the intervention has already been provided to 50 villages, right? They have been purposefully selected. Okay, so I have to come up with a counterfactual. I have to come up with a comparison group. I have to come up with a control group, right? How would I find a control group? I'll simply identify my 50 project villages from this list, and for each of those project villages, I'll find a village that is similar to it based on all these indicators that I mentioned here. So what is their ST category population? What is their ST category population? How many what is the proportion of literates in that district, right? Marginal farmers, all kinds of farmers you mentioned, and then you would want to come up with a composite score. Based on all these indicators, you come up with a composite score. Just compare it with the district or with the village, that is closest to it. That has the least difference between the composite scores. That would be a good match, right? That would be a counterfactual, or that would be a comparison, that would be a control for your treatment area. Simply do that for the remaining 49 villages also. You get a comparison, you take the baseline estimates in the absence of the program, right? The baseline is there with you. You collect the information at the end line. What we are doing is a DID right now. DID can be done, but we also understand these 50, we have matched the villages we've matched for the village characteristics, but we haven't matched the individuals in the villages or the households in the villages, right? I don't have any data set which basically talks about all the households. There is no data set that is available in the public domain that talks about these kinds of characteristics at the household level. It is available at the village level, it is available at the district level, it is also available at the state level, but this kind of an information is not available at the individual level. Maybe it is with the census, but obviously that is not available in the public domain. Okay. Also, there are two ways. So I look for secondary literature, which is basically census or any kind of survey that could have been conducted at the household level. Okay, if I had that household level information, I would have gone for another round of matching. So after matching the villages, I would have matched the individuals in those villages also, right? And that would have been it. But there is no such data set available. Even if you talk about SECC, socio-economic caste and census data, that data is also not available in the public domain, right, for this kind of an analysis. So what do? I have two options. Number one, there is something called listing exercise. Is anyone aware of a listing exercise? You remember we talked about sampling frames? So what is the sampling frame for this group? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 is the population in this group. And if I were to come up with any analysis, that would be on these 25 people. So that becomes my sampling frame also. The selection will happen out of these 25 people only, right? So that becomes my sampling frame. We've been talking about this random assignment for a very long time. How is this random assignment done? So I can enter the room and I can simply point my fingers at 5 people and I can sample them for my study. That does not happen. It doesn't happen that way, right? I need to have a list of all the people sitting in this group with their basic identifiers, their name, phone numbers, right? Their caste profile, caste category, their religion profile, right? The financial status, all of that kind of information, the BPL card, the ration cards, whatever they hold, right? I need that list to randomly select certain individuals for my study. Is that list available now with you? When we're talking about households, that list is not available with us, right? So we have the list of villages and their characteristics, but we don't have the list of households. So either we go to all these 100 villages, of which 50 are project villages, 50 are comparison villages, 50 are treatment villages, 50 are control villages. We go to all these villages, conduct a study in which we are asking them about the basic information, right? And then prepare a list of all the households in these 100 villages. Okay, that is called a listing exercise. It is a very small, simple tool, maybe a 2-pager or 3-pager tool, which basically asks you about very, very basic sort of an information. And based on that kind of an information, you will create a sampling frame from which your sample can be selected. Now that is one way. But then also realize that for listing, you will have to go to all the 100 villages, right? You'll be sending like 2 to 3 people. They'll be staying in one village for one day, collecting the information. it becomes a large exercise in itself. Right? Just to create a sampling frame, you are spending a lot of resources. So to avoid that, what do we do? Let us simply go ahead with a random sampling within each of these 100 villages. Let's say if I were to sample 10 households from each of these villages, right, from each of these 100 villages, so my overall sample size would be 100 multiplied by 10, 1000 households, out of which 500 are treatment households and 500 are control households. I have the entire set of information for these 500 treatment households and 500 control households, right? Then I match them. So post data analysis, I match them. What will happen if I match them? Post data analysis. So if you've collected a detailed, you've administered a detailed questionnaire to this group and a detailed questionnaire to this group. Ideally, you should have done the matching earlier, but you obviously did not have the information. The alternative would be to just to conduct a listing exercise with both these groups, but that would have been resource intensive, right? So I have gone ahead with conducting the survey anyways with these two groups, and post data collection, after the data collection, I am matching these households, right? What happens now? Will all the 500 project households be matched with all the 500 comparison households? They can be matched, right? So let's say that based on a lot of covariates, the kinds of socio-demographic indicators and everything that I talked about, right? I get a score of 50. I'm in this group, I get a score of 50, right? I need to be matched with someone in this group that has a similar score, right? So there is one person with a score of 51. There is another person with a score of 55. Right? Obviously, I'll choose 51 if that person is available. So my characteristics will be matched with the person who has scored a 51. Right? So I'll be able to find a good match. Let's say if my score is 50 and there is no one around 50 at all in their group. Right? The closest match is 75. I can definitely get matched with that household or with that individual. But is that a good match? Is that a good match? So 50-51 is a good match. It is the strength of that relationship or the strength of that matching would be very high. It would be very, very strong. Right? But as the strength of matching between 50 and 75 isn't that strong. Right? That is simple logic. I want the best matched households from both the project and the comparison areas. Right? So what will happen? There will be certain households from the project areas that will not be matched with the comparison areas. There will be a sample loss. And that is the price we pay for matching post data collection. There were two options. Either you match the households, do a listing exercise, match them first, and then conduct the survey. In that case, your sample loss would have been 0. But you did not want to spend such a large resource for a listing exercise. You did not have the resources in place. So you went ahead with a random sampling. Then post data collection, you tried matching these two sets of groups on certain characteristics. There will be certain households in the treatment areas that could not be matched to the households in the comparison areas, which means there will be a sample loss from both treatment and control areas. So after the analysis, you might see a sample loss. It might drop to 450 households. It might drop to 450 households. So now this is a good match. You're saying that these 450 households are a good match, and now you can do a DID there, right? So earlier, let's say if you had done a simple DID without matching, it would have been 20%. But if you do a matching, this number would be higher or lower? Will this number be higher or lower? Or it could be higher or lower both. Usually you would find that the estimate falls down. Estimate decreases. Right, so it might go to 15%, 17%, 12%, and this is a more reliable impact measurement. So if you simply just do a DID, and if your group is not homogeneous, then people might not believe that impact measurement. People might not believe this 20%. But if you do a good sort of a matching, and then calculate the estimates, the baseline estimates, their endline estimates, do a double difference, and then come up with a revised estimate, this is a much more reliable estimate that people will believe. Okay? Simple? So we've discussed about DID, we've discussed about PSN. We'll discuss about the remaining two in very quick detail, okay, when we come to it. So I'll just do a quick recap after the tea break. It's 11:52. Let's call it a tea break, right? And when we come back, I'll just give you a quick recap of what we've discussed since the morning, because I see that almost everyone is getting tired in the first session, which is not a good sign. But let's recap it, and then we talk about the other two kinds of designs, RDD and instrumental variable. Okay, yeah. So this is 11:52 right now. Oh, let's go with this clock. So it's 11:50 almost. Let's come back at 12:05. Right? 15 minutes break. So this is one of the studies that we had conducted in the public health space, and one thing I just wanted to mention here, that there are different kinds of terms that are used. So if you're using experimental designs, the kinds of terms that you'll use for the areas that receive the treatment and the areas that don't receive the treatment are treatment and control. Okay? I need your attention, please. Yeah, so the areas or the people who receive the intervention are called treatment. The ones who don't receive the intervention or receive placebo are called control if you are using an experimental design. But if it is a quasi-experimental design, it becomes the people or the areas that receive the treatment are called project areas, and the people who do not receive the treatment are called comparison areas. So it's just that the terminology changes from experimental to quasi-experimental designs. The meaning actually remains the same. So treatment is called project in quasi-experimental designs. Control is called comparison. So project comparison is the terminology that we use in quasi-experimental designs. In experimental, we use treatment and control. Okay. Now this was one of the studies that we had conducted some time back to understand the implications of propensity score matching, PSM, propensity score matching. Okay. If you look at the sample size before matching, it was 4,448 households, and the control was 4,356 households. Okay. If you look at after matching, as I mentioned, there will be a sample loss. So if you remember in our example also, there was a sample loss of 50 after matching, right? So once we did the matching, the sample fell from 4,448 households to 3,504 households, and in the control it fell to 3,366. So one thing we can see that in most times, if you go ahead with the matching, there will be a larger sample loss in the control areas or in the comparison areas as compared to the project areas. Right? So there was a larger sample loss, 4448 minus 3508 and 4356, 3356. If you look at in terms of percentages, we lost a sample of 22%, 22.7% in the control areas, and then we lost 21.2% in the treatment of the project areas. Okay. So every time you go ahead with the propensity score matching, just ensure that you have already inflated your sample by 20 to 30%, because once we go ahead with the matching, this percent will definitely go down. Okay. If you look at the before matching situation, the DID was coming to 4.5%. That was the net impact of the project that we were getting. But after matching, it came to 2.4%. So the estimate reduced from 4.5% to 2.4%. Right? But 2.4% is a more reliable estimate. Okay, 4.5% is not a reliable estimate. Okay, now I'll just quickly touch upon two other designs that are used, RDDs and regression discontinuity. Okay. Can you see these two graphs here? Very simple graphs, right? Okay. So let's say you've asked certain questions to certain households. Let's say to 10,000 households, you've asked certain questions just to understand their poverty status or their financial status. Okay. So you've asked them whether they own a household, right? Whether they own some land, how much land do they own, right? Do they have an agricultural land? What are the different sources, or how many earning members are there in the household? Right. So you ask many of those questions, and based on those questions, you actually want to come up with a baseline poverty index. Okay. So poverty index, so for example, you might have a cutoff score of households who are earning an income of 58,400 rupees. Okay, how did I come up at 58,400 rupees? Can anyone tell me? So according to one of the definitions that was adopted by, or that was proposed by the Dilkar committee in 2014, you would remember that the definition said that households in the rural areas who are earning 23 rupees per person per household fall under the below poverty line category. And there are usually around 5 members in each household. So 22 into 5 is around 110, 120 rupees, right? If you extrapolate this for the entire month, it might come to around how much? 3,600 rupees. If you extrapolate it for the entire year, I think it comes to around 56 or 58,000 rupees. I think it was 4,800 rupees for the entire month, and then if you extrapolate it, it comes to around 56 or 58,000 rupees, right? So that's why I'm talking about that. Now let's say you've collected some information about daily household expenditures on food. Daily household expenditures on food, and you've interviewed some households, right? And you've plotted that graph with x-axis being baseline poverty index. So poverty index, we just talked about, we've asked them a lot of questions, and based on that we've come up with a composite score, and that composite score value is ranging basically from 20 to 80. Okay, so with this the household expenditures have been mapped for food, right? So it will be something like this kind of a structure, right? Now remember we talked about y is equal to mx plus c yesterday. We basically, so y is equal to mx plus c is basically a line that is equidistant from all the points in that graph. So a line that fits between all these points is called a line of best fit. Again a jargon, it is called a line of best fit, which is basically a line that simply goes through the middle of all these points. It is basically, if you plot the center point for all these points that are mentioned here, you will get this line. Okay, so that's how this line has come up. Now, this is where RDD starts, regression discontinuity design starts. You have this graph with you already. Okay, let's assume that your program has a cutoff of certain percentage points. So, for example, people who are falling in the poverty index lesser than 50, whose scores are lesser than 50, they will be eligible for receiving the program benefits. Obviously, people who are falling less than 50 will be poorer to people who are falling above 50. Simple, right? So people who are poorer than 50 are basically they are eligible to receive the intervention. Right? They are eligible to receive the intervention. People who are falling in the income range or in the basic poverty index ranging above 50, they are not eligible to receive the program. Simple. We have a cutoff in place. Okay. So this 50 is the cutoff. Okay. So what do we need in a regression discontinuity design? We need a cutoff that is agreed upon by everyone. We need a very, very clear cutoff. Okay. So we have a cutoff at 50%, which basically demarcates who will receive the intervention and who will not receive the intervention. Okay. Now there are two more important things that we had talked about. Homogeneity and randomness. These two are very, very important for any evaluation. Right? Now, how do we ensure that this sample or the sample that we are trying to assume is homogeneous? So obviously this becomes the treatment area, right? Because these people are getting the treatment, these people form the treatment group and these people form the control group, right? But are they similar? Are people in this group similar to the people in this group? They are not similar, right? Because if you look, this is the poverty index. This is the expenditure. Their expenditure is lesser than their expenditure, right? Their poverty score is lesser than their poverty score. So these two groups are not homogeneous. They are not comparable. So how can I consider the entire of this group to be treatment group and the entire of this group to be control group? Because I am not comparing apples to apples. The entire point of an evaluation is to compare apples to apples and not to oranges. So the maximum of your time as an evaluator goes into just matching the two groups so that they are similar to begin with, and towards the end line, if there is any change that can be attributed to the program. Okay. So obviously I cannot take the entire bit of this group similar to entire bit of this group. But what can I do? I can take a very, very small cross section, say this much, closer to the cutoff area. If I look at this sample that falls between, say, this is 50. Let's say I'm taking a sample that falls between 48 to 52. Okay, so I'm taking the sample that has a poverty score between 48 to 52. This is a marginal difference. They are very close to the cutoff area, right? So 48 to 50 can be considered as the treatment group, 50 to 52 as the control group. Am I right in saying this? You work with assumptions, right? So in most cases, if you see many of these households will be similar. They're having the same score. If you look at these two dots, they are similar. If you look at these two dots, they are similar. Right? So the households which are in that range, 48 to 52, they are basically comparable. They can be assumed to be a homogeneous group. But if I take this entire group along with this, these are not comparable groups. But the households that fall within a very, very small cross section in either side of the cutoff point, they can be considered to be a homogeneous group. Right? Two things we talked about right now. We need a cutoff point, cutoff score. Right? And we need to identify a particular area where the households are similar to each other, or can be assumed to be similar to each other. Let's say that range is 48 to 52. Okay, so 48 to 50 becomes the treatment area, and 50 to 52 becomes the control area. Okay, so homogeneity is checked, right? What happens to randomness? What happens to randomness? You basically plotted the expenditure on food for all the households, let's say for 10,000 households here, right? And you're simply looking at a very, very small sample size. So that is a random assignment, right? You did not have a list here, but still you could simply put certain households in certain category and certain households in the treatment category or the control category. So randomness is also checked, right? Now once that is done, let us say the intervention is provided to 48 to 50, that is a treatment group, and let's say towards the end line, when we plot their household expenditures on food vis-a-vis the baseline poverty index again at 50. So 50 was a cutoff point here, 50 is the cutoff point here, right? Their expenditures have gone up on food. They are consuming better food. They are spending more on food right now. Because their incomes have gone up, they are also spending more on food. Okay, so that was the treatment. So because of the treatment, because of the intervention, their expenditure on food has gone up, right? And if you would want to fit a straight line, which is basically a regression equation, this will be the line of best fit here. Similarly, for the control areas, their situation almost remains the same. Okay, so this is the line of best fit for them. The difference between point A and point B is basically the impact of the program. Simple? Simple? I'll say it again. First of all, we come up with the score based on certain questions that we asked, right? And then we plotted the food expenditures on the y-axis. This was a very, very continuous sort of a line. We fit a line of best fit here. Obviously, this group cannot be considered to be a treatment group and this cannot be considered to be a control group because they are not comparable by any means. But we've identified a cutoff point first, and then the households that fall in very, very close cross sections on either side of the cutoff point, they can be considered to be a homogeneous group. Let's say 48 to 52. So 48 to 50 becomes the treatment group because you provide the treatment to them. And then 50 to 52 could be your control group, right? At the end line, after providing the intervention, let us say their food expenditures have gone up, right? and the food expenditures, because they're consuming better food now, and their food expenditures remain the same. The controlled food expenditures remain the same. So the differences between A and point B, this difference is actually the impact of the program. Simple. In which kinds of situations would you want to use this kind of a design? I'll just give you an example. Just have a look at this case study. A food distribution policy has been launched by the government in a national emergency situation. Households have been assigned an index based on their economic situation and distance from the food distribution center. It is a 3-point index. Category 1 will be provided 100% subsidy on food grains. Category 2 will be provided 50% and Category 3 will be provided 20% subsidy. Propose a design to measure the impact of providing subsidy on food consumption scores of households. What is the intervention here? Food subsidy. Food subsidy is the intervention here, right? We have 3 categories here. Okay, we mentioned 3 cutoff points here. Simple. So for each of these cutoff points, what are we going to do? We are going to look at the households which are very close to the cutoff point on either side. The households on either side become your treatment and control areas. You provide the intervention to them. After this program has been conducted, say after 6 months, you would want to do an evaluation of what has been the impact on food consumption of these households, right? The treatment score would have gone up, or the expenditures for food would have gone up, or maybe come down, right? And for the control, it would have remained the same, right? So the differences between the baseline and the end line would actually give you the impact of the project. Simple. Any confusion here? You need a clear cutoff point for all these kinds of designs. For an RDD, you need a clear cutoff point. If you don't have a clear cutoff point, you will have to create one. Okay, so let's say they did not mention anything. They just said that people who are below the poverty line, we will provide them some kind of a subsidy. So what would you do? Give me a solution. The government has said that there is no clear cutoff point. We are simply going to provide subsidy on food for people who are below poverty line. How do we identify households that are falling below the poverty line? What is the proxy? Do they have a card? Right? BPL cards. So you know for sure, and if you have a list of people who have, first of all, you will have to plot their current expenditures on food on the y-axis, and then on the x-axis there would be a score based on the cards that you've received. People, and there's a very cutoff point, a clear cutoff point, people who have cards and people who don't have cards. People on either side, you can consider to be treatment. On the left hand side would be considered to be treatment. People on the right hand side would be considered to be control. Then you provide the intervention to them. People who have been provided the subsidy, their expenditures would come down, right? And then instead of this kind, so if you're providing subsidies, what will happen to the treatment line? Will it be like this? This line would actually go here, right? The expenditures on food will fall because you are providing food subsidy, right? So this will come here. It doesn't matter, it's going to be a positive or a negative impact. Any impact is positive. Basically, Subsidy was supposed to reduce your expenses, right? So again, point A minus point B will give you the impact of the project. Simple,
Only then purposes will not there.
right?
Because BPL cards will not give you the actual,
Right?
range of the
Yeah, yeah.
actual range. How do you
Right, right. Very simple. So in that case, you simply do ownership. You say that people who own the card, people who don't own the card, right? That becomes the cutoff. You plot their expenditures here. And then you fit a straight line to it. People who are falling in this region basically become your treatment. People who are falling in this region become your control. Right? You provide them the treatment. After the treatment, their expenditures would be somewhat like this. Right? And in the control areas, their expenditure would be somewhat like this. The difference between these 2 points gives you the impact of the project. Is this correct? But sir, you raised a very important point. Look at the x-axis. Can the value be 0, 1 there? So you will have to instead ask them certain questions. Remember the example that we were talking about. The previous example, in this example, I was talking about a composite score, right? In which we are going to ask them a lot of questions. Do they own a land? Do they own any farm? How many members in the household are owning? Right? How many homes do they have? Right? Whether they own a tractor, whether they own a sofa, whether they own a mobile phone, right? Based on all these indicators, you come up with a composite score. That composite score can be plotted on the x-axis. That is a score. 0, 1, the ownership of card might not give you a very clear description of which of the households are falling below poverty line and which of the households are falling above the poverty line. Also, if you see practically, these cards were distributed long back in 2000s, right? And if you go to survey the households, they would still have the BPL card. Maybe they have moved much higher in the social category or in the social stature, but they'll still have the BPL card, and they'll still be drawing some kind of a benefit from the ration shops, which is perfectly fine. The government doesn't look into it. The government looks the other way because it's a welfare government, right? At the end of the day. So, in that case, your BPL card will not be a true indicator that you can use here. You'll always have to come up with certain kind of indicator. Either you create that indicator based on some secondary information that is available. Maybe NFHS has collected some data, right? Maybe NSSO, National Sample Survey Organization, has collected some data. You look into all those data points, you identify the households that are on either side, you go ahead with it. But the major problem, there are 2 to 3 major problems with this kind of a design. It is a very, very good design. It is not as great as an RCT, but better than DID and PSA. If we are able to do this properly. Okay. There are a few issues with this design. Can anyone tell me what are the issues? So one is, as sir mentioned, it is very difficult to come up with a composite index for the households because we are talking about household level data. Either you collect that data for all the households first, which is going to be a humongous task, right? Or you get it from some secondary literature, then plot it there. But again, that is also going to be an exercise. Most of the times you might not have that kind of information. So RDD's major limitation is creating the index, and that index cannot be a very ad hoc sort of an index. It has to be a very reliable index that is backed by literature, that is backed by science, that is backed by mathematics. Okay, it cannot be a very simple sort of an indicator. Everyone has to agree to it. So creating an index is definitely a challenge. What are the other challenges? Say I give you a situation. Let's say we've plotted all these dots that I've plotted is of a sample of 1,000 households. 1,000 households, right? Let us say between 48 to 52, there are 200 households. Oh, sorry, this is too large. So let's say between 48 to 52, there are almost like, say, 60 households. Okay, in this range, there are 60 households, right? Out of which, say, 35 are treatment, 25 are control. So that's where the first problem lies. It is not a balanced matching, or it's not a balanced group, because the sample sizes in the treatment and control are different. Okay, so that is the second flaw. The first flaw we have already discussed. The second flaw is this. Right, now there is a third flaw. You remember we talked about inferential statistics a long time back. So we said that if I were to look into a sampling frame of 1 crore and I have interviewed like 10 lakh people in one study, and in another study I have interviewed only 1,000 people, and we talked about tolerance, we talked about range. So 20% change plus or minus 2. That might be the situation in the kind of survey that we are conducting with 10 lakh people. But for a survey that I'm conducting with only 1,000 people, the situation might be like 20% plus or minus 10%. Okay, so sample sizes are also very important. Now, for a sampling frame of 1,000, if I'm giving my estimates on a sample of 60 only, does that hold true? Will that be sufficient? People might think that it has happened because of chance only. Maybe I've selected 35 very good people here, and that's why my estimates are much better. Right? So that becomes a challenge. The sample size in this group is not a true representation of the entire population, and that's where this design has a major problem. The external validity, the generalizability of the findings emerging out of an RDD in most situations cannot be considered true for the entire population. So that is one major limitation that RDD has. How can we mitigate that? Any suggestions? So what we are saying that the number of members in this part are very less, right? And they cannot be a true representation of the entire population. What can we do to mitigate this kind of a solution? It's a very logical solution. Is it okay if I assume the number of households not between 48 to 52, I increase the range on either side. I keep it from 40 to 60. Right? Now for that, if I have a more horizontal line or a lesser steeper line, then I would find more households having similar characteristics. Right? If the households were spread like this, obviously I cannot compare these two. because one dot will be here, the other dot will be here, one dot will be here, the other dot will be here, right? But in this kind of a situation where the line is not steep, I can increase the range around the cutoff point. I can take it from 30 to 60. Sorry, I can take it from 40 to 60. I can also take it, if it is very horizontal, then I can extend it to 20 to 80 also, right? So it completely depends on the distribution that you have, right? The steeper it is, the more the difficult situation you are in. Obviously, your cutoff point has to be very close to the range has to be very close to the cutoff point. If it is not that steep, then you can go ahead with a larger range. Okay, larger range means the sample size is larger, which means your findings that emerge out from the study can be generalized for the population. Simple. So that is RDD, regression discontinuity design. Again, a very fancy term. Don't go by the name. The name is a misnomer, but it's a very simple design if you have all the basic information already in place. If you don't, then please don't go ahead with this design at all. Right. I'm coming to the last design now, which is instrumental variable. It is also called randomized promotion. It is a design which is not as good as RCTs, but very close to RCT also. And that is the last design for the day. Okay, so we won't talk about newer designs after this. We'll have a lot of case studies, as you would have seen, that we can talk about. The last design. If it is getting too technical, I won't get too much into it. Okay, instrumental variable. The last design. Okay. When is this design used? I'll set the context first. This design is used for programs with the universal coverage. Please remember this one sentence, and then it will get very easy for you to implement this design or propose this design. This design is used for programs, schemes, interventions with a universal coverage. What do I mean with a universal coverage? They're open for all. There is no cutoff point. There is nothing that says that these people will be beneficiaries and these people will not be beneficiaries. This program is available for all. Right. Give me an example of a few of these kinds of programs that are available for all. Sorry? Health systems, yes, that is available for everyone. What else? Vaccines available for everyone.
Yes, I do.
AIDS programs. Yeah. Right. What else? SBM was also one of the examples. Right? People, it's not only about toilets, right? It's about sanitation also. JJM. That was also available for everyone. Right? So these are some of the programs that have a universal coverage. It is open for everyone. Anyone who wants to avail it can avail it. Right? So whenever this kind of a situation happens, there are always three kinds of people. Okay, so this design basically categorizes people into three different categories. It says that no matter what situation happens, there will be always three kinds of people. People, first category, they are the most pessimistic people. Never enroll. The second category, super optimistic people. They will always enroll. They're just waiting for the government to come up with something and they will enroll. And then there's a category in the middle. If you reach out to them, if you make them aware of what are the benefits of that product or that scheme, if you have some promotion campaigns around that scheme, right? If they're slightly made aware of the advantages of that particular scheme, they will adopt it. They will enroll it. So, enroll if promoted. Three kinds of people. Right? There is not the fourth kind, can't say. Can't say is not an option here. Right? So, this design simply looks at these three kinds of people. Never enroll, no matter what you do, these guys won't ever enroll. Always enroll? Yeah. Yes. Yeah, that is the situation everywhere. Not in the state, it will be the situation everywhere. So this design is adopted globally. It goes beyond the state or the country lines. So this is available for all kinds of people. So globally there will be kinds of people who will never enroll, no matter what you do. Okay. So you need to come up with some promotion instrument. That's why it is called randomized promotion, or it is called instrumental variable. So you need to come up with certain things, or maybe one activity for which you reach out to different kinds of people and you try and promote the program. Now, please listen to this very, very carefully. The last 3 points are very, very important. What does it say? It says the same thing that we talked about in regression discontinuity. It says that the promoted and the non-promoted groups must be comparable. So the groups or the people that have received the promotion, their characteristics must be similar to the groups of people that have not received the promotion. Homogeneity, right? Instrumental variable should be effective enough to increase enrollment substantially among enrolled if promoted group. So this category, whatever promotion that you are coming up with, it should be effective also, so that their enrolled as promoted, this should go up substantially. Right? This is also a challenge for this design. It says substantially it should go up. How do you define substantially? How do you define substantially? So for example, if I'm talking about institutional delivery, right? If you talk about institutional delivery, the percentages of what are the proportions like? If anyone's been working in the public health space, what are the proportions for institutional delivery? It's closer to 97%, 97-98%. So most of the women are having institutional delivery these days. Okay, so 97-98 degree, how much can you improve it further? No matter what promotion you do, you cannot go beyond 100%, right? So it has to be effective. In that case, even a 1% change, if your promotion is able to get a 1% change, that is also substantial. Maybe for some other program, 50% change might be a substantial change, right? So this is one of the major loopholes for this instrumental variable or randomized promotion design. Okay, okay. Let's forget about the challenges right now. Let's come to what we need to do. Okay, so the promotion thing has to be very effective so that there is a substantial change in the enrollment in the third category. Promotion activity should not affect the outcome of interest. There are three terms that we need to think about: enroll, promote, adopt. Okay, we were talking about enrollment here. Enrollment is simply applying for a certain program or being a participant to certain scheme, participant to certain program. Right? It does not mean that simply by enrolling in certain program or a scheme, you start availing the benefits of that scheme. When you start availing the benefits of the scheme, that means you've moved into the realm of adoption. Okay? Enroll is simply getting your name there. Adoption is when you start availing the program benefits, and promote, what they're talking about is that the promotion should be very good, but it should not directly influence or directly lead to adoption. It should indirectly lead to adoption. Which is what is the outcome of interest here? Outcome of interest here is adoption. People should adopt the program. People should get the benefits of the scheme, right? What they're saying is you have to come up with a promotion strategy that increases enrollment but does not directly impact the adoption. How is this possible? Can we have this kind of a strategy? Let's take an example. We're talking about government schools. Okay. And there are certain government schools, and there's a universal policy by the government now that an adaptive learning platform will be provided to the children in the government schools. You are aware of an adaptive learning platform, no? So, for example, if I were to learn evaluation on a tablet, so a tablet will be given to me. There will be a lot of modules that will be taught to me first, and then there will be questions, just to test how much have I been able to recollect, have I actually learned. Okay, so it basically is a machine learning algorithm. So it will ask you the simplest of questions first. What is evaluation? And then it will give you 4 options. If you are able to answer this correctly, then it will raise the bar. Okay, it will ask you a slightly more tougher question. Then if you are able to answer that also, then it will ask you a slightly more tougher question. Then if you are able to answer that also, then the machine gets the feeling that this guy is actually good. Let me increase the difficulty level for him. Right? That is machine learning. That is machine learning algorithm, right? So it will keep on giving you harder questions, and if you keep giving the right answers, then obviously the level of hard questions goes to a different level, right? But adaptive learning platform, as the name suggests, not every person will always give the right answers. So let's say you've given 3 right answers for difficult questions. The 4th question you could not answer. So the machine will understand that probably I need to fall back. I need to give him a slightly easier question. So it will give you, for the 4th question or the 5th question, a slightly easier question. If you are still not able to answer it, then it will give you a more easier question or an easier question. Then if you are able to answer it, then a notch above. If you are able to answer it, notch above. If you are able to answer it, notch above. If you are not able to answer it, Call back. Call back. Right. So this kinds of adaptive platforms are being used very widely these days. There are a lot of, this is basically, this is more better for the cognitive ability of the children these days, and then you learn faster. Right. So this kind of an intervention is being provided to all the government schools in India. Let's say this is the intervention. Okay. What will be a randomized promotion? What will be a promotion? If you were to develop a promotion instrument that only increases the enrollment of the children in the government schools and does not increase their adoption of this kind of a adaptive learning platform, what would you do in your promotion strategy? You're getting my point, right? What would you do? Okay, if I do a household visit or door-to-door visit or community visits, which house door-to-door might not be possible for all the households in India, but let's say if I just put hoardings somewhere, say on the panchayat office, I put a hoarding in the panchayat office. Let's assume that it is always at the center of the village. Everyone who passes by looks at the hoarding that is there on the panchayat office. Right? You would have also seen a lot of messages being written on the panchayat office about family planning and all those kinds of things. Right? There's a reason for it. People who pass by, maybe the location of the panchayat office is at the center of the center. That's why it becomes a very good platform to share all that kind of information. Okay, so you've put a hoarding there. Everyone who passes by looks at that hoarding and says, oh, okay, that's good. So much good work that the government is doing these days. How about I put my child one of the child probably has dropped out. So that person would want to put that child back into the education system. What is happening here? Your promotion strategy is increasing the enrollment. But it does not mean that you are increasing the adoption for the adaptive learning platform directly. But if your child gets enrolled into the government program or in the government school, then obviously that the child will get the benefit of the adaptive learning platform. Okay, so it's an indirect way of promotion. Now, there are a lot of arguments to it. The promotion strategy, whenever you devise it, will have a lot of arguments. There will be evaluators sitting on both sides of the fence. Some people would say, oh, that's a fantastic strategy. Kudos to you. You've come up with such a good strategy that is simply increasing the enrollment and is not affecting the adoption of the adaptive learning platform at all. Very nice. People who are sitting on the other side of the fence would say, oh, if you are increasing the enrollment, obviously you are increasing the adoption because this policy is available for all the children in the government schools. Right? Now, in that case, if your adaptive learning platform is available, is open for all the children in the government schools, but people can or the students can choose not to be a participant in it, then it is a good enough strategy. We need to have these three people there. Three kinds of people should be there. The policy is open for all the children in the government schools. The children who are interested, if promoted or if they should be able to join it. People who are, there are children, the front benchers, they would always be like, yes, I'll enroll. Right? I'll definitely be a part of this. So they will enroll anyway. And you also need to have a third category of children who are least interested, right? Who don't want to be a part of it at all. Okay. So if we have these three kinds of children, that's a good enough instrument. We go ahead with it. Okay. So that is basically the precursor to just getting into randomized promotion. Now what happens is that you have two kinds of groups now. You have two types of groups here. A promoted group and a non-promoted group. Right? Look at the example here. Okay, let's look at the example here. The first one is a never enrolled group. You would see the faces of two children here and the faces of two children here. This is the promoted group, this is the non-promoted group. Okay, so what we are trying to say here, that if this entire population was a homogeneous group, right, that the children in all these three groups are behaving, or sorry, in the promoted and the non-promoted groups are similar, right? So you would have like X number of children here, X number of children here, right? So at the end of the day, if you look into the difference between these two groups, there would be no difference because it is a homogeneous group. That is the assumption of the design. Usually, in all practical scenarios, this does not happen. There is a difference between these two groups also. We'll come to that later. Okay. This design says ideally this should be the situation, right? And group number 2, always enroll. They will also have the same situation because it's a homogeneous group. So no matter whether you provide them any promotion or don't provide them any promotion, by their inherent nature, they will enroll for the program, right? So you would largely see no difference. There is only one group that will show some difference, which will be this group, and there will be a difference here. Okay. Now let's say how do I say this? Okay. So let's say you have promoted, this was the promoted group, right? And this was the non-promoted group, right? Let's say when you're looking into the adoption for this group has gone up to 80%. Earlier there was no adoption, 0% was the situation before the implementation of the program. Let's say for this group it has gone up to 50%, right? Without promotion, the situation is at 50%. With promotion, the situation is at 80%. The mathematics is very simple. 30% is the net impact of the project. Simple. It comes with a lot of assumptions. This design comes with a lot of assumptions. It looks simple, but it's very, very difficult to do this in actual practice. Okay. Yeah. So how do we go about it? What are the different kinds of assumptions here? Promotion should not directly impact the adoption. This is basically a homogeneous group that we have, right? Always enroll will always behave like always enroll. Never enroll will always behave like a never enroll, which is usually not the case. right? So what will happen is let's say it is a 50%, sorry, it is a 0% here, and it has increased to 10% here. Let's say here was 100%, this has dropped to 80% for some reason. It happens, right? So this would be a plus 10% change, this would be a minus 20% change, and this is a 30% change, right? So you'll have to simply do 30% minus 10% plus 20%. So it basically becomes a 40% change overall. You have to do away with the other two changes as well over a period of time, right? So that's the simple design we have, with a lot of assumptions, risks and assumptions that are mentioned here. But that is the only option for kinds of programs with a universal coverage. Okay, so I have a few case studies with me here, and I'll put that on the screen. I would request you to tell me one by one what kind of a design could be used for each of them. And then we close the session on evaluation designs. Okay, sorry. Before we move on to that, let's say you don't have the option of going ahead with an experimental or a non-experimental designs. What do we do? Always remember, an experimental or a quasi-experimental design has a counterfactual or a control group in place or a comparison in place, right? Or non-experimental design is a design which does not have this. Why is a comparison group required? Why is a comparison group required? Obviously to compare, but compare what? Can you see this graph? Can you see this graph? Okay, so let's say that this is a comparison group that you've identified. This is the outcome indicator if you're plotting this value over a period of time from year 0 to year 1. This is a 1-year intervention that you're looking at. Okay. So what happens is, if you look into the values in both these situations, so the value at the baseline, is 0.0. Treatment enrolled. Let's look into the enrollment. Enrollment is majorly the outcome as a part of this program. Okay. So if you look at the before characteristic, which is baseline, which is basically the baseline characteristics, 60% of the children were enrolled. Now if you look at the comparison, it was 78%, 0.78. Okay, 60% was the situation for the treatment, 78% was the situation for the control. It was the 78% of the children were enrolled. Okay, if you do a difference, it is minus 0.18, 18 percentage point difference, right? Now after the intervention has been provided, so this is the intervention duration, right? What happens is that the control will keep on going with the same trend. It will also have a positive trend. It might also be following a secular trend, right? And from this point onwards, you would see a positive for the treatment area. So this is basically the treatment impact if you see the difference between these two, right? So after treatment, the enrollment has jumped from 0.60 to 0.74, right? It has moved from 0.60 to 0.74. If you look at the comparison, it has moved from 0.78 to 0.81, 0.78 to 0.81, right? The difference here was of 18 percentage points, the difference here is of 7 percentage points. It simply goes on to say the difference of difference is 11 percentage points, which means that the program's impact has been 11% on the enrollment of the children. Simple. If I simply just transpose this graph, the controls graph, here at point A, this will look something like this. Got my point? Right? This graph, if I simply transpose it here and then I subtract these 2 points, is going to basically give me 11 percentage points difference, and this is the impact of the project. So we basically need a counterfactual or a control just to understand what would have happened in the absence of the project and with a project in place. What is the difference? So in the absence of the project, in the absence of the program, A would have also followed the same trajectory. There would have been hardly any difference. But because A has received a treatment, it has gone to point B, which is 0.74, and the difference between these 2 points is 11%, which means that the enrollment of the children because of the intervention has increased by 11 percentage points. Simple. That's what DID is basically giving you. So non-experimental designs, coming to non-experimental designs, in which you don't have a counterfactual, don't have a control at all. What kinds of designs can you use? You can use a pre-test, post-test design. Just in the project areas, you go and conduct a baseline study and an endline study. You don't have a counterfactual baseline and endline. Okay? So that is a pre-test, post-test assessment. What are the problems with the pre-test, post-test assessment? These are the same problems with a non-experimental design. This could have happened by chance. So for example, if your pre-test, post-test assessment tell you that there has been an 8% change from the baseline without having any information about control, which means that it might have just happened by chance, or it might be just a secular trend. By secular trend, I mean that it would have anyways happened. 8% would have anyways happened. There is no major contribution that your project has put into getting that 8%. If you had a control, probably the control would have also experienced an 8% change. You can't say that because you don't have a control, right? So unfortunately, that's where the non-experimental designs are not that great. Now, how do you mitigate this kind of a situation? You back it up with a lot of secondary data. Now, if there is secondary data available, say if the enrollment data is available on DICE website, you can get the information for your project in comparison areas and say that yes, your project has worked in the project your intervention has worked in the project areas better as compared to the comparison areas. You can also do a lot of qualitative interviews to back your findings. Okay, so non-experimental designs, you will need a lot of different kinds of information to back your data, right? It gets very difficult to actually just stand on the shoulders of this design and claim that your intervention has worked. Okay, the second is the time series data. You collect data for say the same set of people over a period of time, but again then you don't have a comparison in place. You're only talking about your project beneficiaries in year 1, year 2, year 3, year 4, year 5, and then you see what has been the trend in your outcome indicator from year 1 to year 10, right? Time series data. Longitudinal study. So time series is also part of the longitudinal study. You go to the same set of people over a period of time. or maybe you go to the same set of people who share a similar characteristic over a period of time, right? But then you don't have a counterfactual, so whatever the findings that you come up with might have happened by chance. So you back it up with a lot of secondary data, you back it up with a lot of qualitative findings to say yes, your project has worked. Simple? Okay. So this is one of the case studies. I'll just increase the font size here. Just tell me the design that we will adopt. The government has decided to evaluate a 3-year-long program that aims to measure the impact of the net annual household income due to the state-sponsored National Livelihoods Project. You have been requested to propose a suitable evaluation design. Please propose a few options while listing the advantages and disadvantages of using each of these designs. So it's a 3-year-long program aimed at impacting the net annual household income. Now please propose a few designs with their options, with their advantages and disadvantages. How do we go ahead with it? Please remember one of the first things that I mentioned yesterday, and I've been iterating today also. As evaluators, we are very, very pessimistic people. Very, very inquisitive and very, very pessimistic people. So, obviously, this information that is provided here is not sufficient. Is it sufficient to propose a design? As an evaluator, one needs to ask a lot of questions. So ask all these questions. Do you have a theory of change, a results framework, a KPI matrix, an LFA in place? By KPI matrix are simply the key performance indicator list, right? Do you have any of these information available with you? You also need to get a sense on when are you onboarded as an evaluator. Are you onboarded towards the end line? Are you onboarded when the project has not started? Are you onboarded when the project areas have already been finalized? So when are you getting onboarded? What do you want to measure? Which are the key indicators that you would want to find answers to? What is that evaluation question? So you don't start an evaluation without getting the evaluation question in place. Okay. You will only seek something when you have an agenda on mind. You have a question that you are seeking answers to. In which areas is being conducted? Do you want estimates at the project level or national level or subdivision level? What do you mean by this sentence? Can anyone tell me? Do you want estimates at the project level or national level or subdivision level? Sorry? Extrapolation. Yes. We are talking about inferential statistics. We are whether your findings are generalizable for the entire project area, whether your findings are generalizable for the entire country, or whether your findings are generalizable for the subdivision level. So at what estimates and what kind of estimates do you want? If possible, also tell us about the overall resources that are available for the study, so that we can take a more informed decision on what should be the sample size, right? Right. All these questions need to be asked, and many more. You might want to go for an exposure visit just to understand what the intervention is all about, right? You might want to get a lot of project documents from the government or from the client before you take a call on what kind of an evaluation design you should propose. You might want to get a sense of whether the government wants to conduct the implementation in one go or will it be conducted in different phases. Right? Okay, all these kinds of questions one needs to definitely ask. Okay, let's go to case study number 2. The Amazing Foundation has developed an innovative AI-powered technological solution to address the issue of pests in cotton cultivation. It helps the farmers detect an infestation, area of infestation, type of pesticide required, and amount of pesticide with video tutorials on the app, which can be used in offline mode also. It also helps get free online consultations with experts. This helps reduce farmers' input costs and time and prevent crop loss. You are required to propose an evaluation design to check the effectiveness of the mobile app and its effect on the yield. Please suggest a design while mentioning the reasons for not opting other designs. What is the intervention here? AI-based technological solution, which is basically helping you reduce pest infestation. Right? What is the outcome indicator? Better crop yields. So improving or increasing the yield is the outcome indicator. Right? What kinds of design can you propose for this? Okay, so I'll list the designs again just in case if you've forgotten them. Experimental, RCTs, step-wedged, quasi-experimental, difference and difference, propensity score matching, RD, regression discontinuity design, and IV or randomized promotion. Which of these designs will you adopt and why? Okay, if it is so confusing, let us start one by one. Can RCTs be adopted here? What is the requirement for an RCT? Treatment and control groups, right? You know the farmers that could be put into treatment group. You know the farmers that could be put into control group. Who could be the farmers that could be put into the control group? Anyone? So this is an app, right? Let's say it is happening in the state of Meghalaya, in one district. Okay? You go to certain farmers, you give them this app, and they are randomly sampled. Okay? You have the list of all the farmers in a particular district. You simply provide the intervention to half of them. You do not provide the intervention to the remaining half. Okay? Right? And before providing the intervention, what do? You get their baseline estimates in place. Do you require 2 rounds of data collection in an RCT? Ideally, you don't. But just in case, you've taken the baseline estimates also. Towards the end line, you go and simply see what has been the difference between the yield in both these areas or in both these groups. That gives you the impact of your project, of your intervention, of this app. Right? RCT is possible. Would you go for an individual RCT or would you go for a cluster randomized control trial? Why would you go for a cluster and not for an individual randomized control trial? I mean, both are possible. If you have the resources, if you have the list of all the farmers, why not go for an individual randomized control trial? A CRCT will always be, in this kind of a situation, a secondary option, right? If you have the list of all the farmers in your project area, go ahead with an individual RCT. If you don't have the list, go for a cluster randomized control trial, right? Then you get certain villages. You say that in this district there are 50 villages. I'll give the intervention to the farmers of 25 villages and not give the intervention to the remaining 25 farmers of the remaining 25 villages. Right? And then I'll see the difference in the yields of both these groups later after providing the intervention. Right? Simple. So an RCT is possible, a CRCT is also possible. What is another challenge in an RCT? One is a major challenge for RCTs is ethical considerations. You are providing interventions to certain people. Let's say this is still a technological app. Let's say you were providing, right, or maybe you were providing some subsidy to some people in the situation of a natural disaster, right? Can you go up to some people saying that I'll give you some food, I'll give food to this group, I'll not give food to this group because I want to conduct an experiment, right? That is not ethical. So that's why it becomes a problem. That's why comes the second step, that one of the mitigation measures for RCTs is that you tell the people that for this phase you will be getting the intervention, you will not be getting the intervention. In the next phase you will also start getting the intervention. Right. So that's why I said RCTs are majorly used for small scale interventions so that you are able to scale up your intervention later. Okay. Can we use a stepwise design? Stepwise design is used when? Phase-wise implementation. Is this intervention happening in a phase-wise manner? No? How many of us say yes? This is not a phase-wise implementation, it is going to happen in one go, right? So a stepwise design is not possible, right? Which is the other one? Let's say if the experimental designs are not possible. If we have purposely looked into that, we will be providing interventions to 25 of these villages, right? Then what do we do in DID? We find another 25 villages which are similar to the villages that we have, right? Maybe from the same geography. We simply draw a random sample of 25 villages, right? Give the treatment to the first group, not give the treatment to the other group. See what is the difference. We do a baseline and an end line. Find the differences between the double difference. Will give us the impact of the program. Simple. When do we use a PSL? In conjunction with the DID, we say it's good that you've randomly sampled some 25 villages, but we also need to identify whether we've captured information from apples to apples for comparison for apples to apples, right? So we collect some information regarding the socio-demographic profile. What was the caste? What was the religion? What was the age? Right? What's the geography that they come from? What are the different kinds of crops that they grow? Right? So all of that information is taken from both these groups, and post data collection I just match that. What happens after matching? Sample loss. Sample loss happens in both the treatment of the control areas, sample drops, and then I look into the revised estimates to a double difference, then I get the situation. What if you are onboarded at the endline stage? Say you don't have a baseline in place at all, right? For this kind of an assignment, if you don't have a baseline at all, what will you do? You've been invited as an evaluator towards the end line. What will you do? You use a propensity score matching with a single difference. The example now that we talked about was a propensity score matching with a double difference, wherein you have a baseline in place. Then you use a propensity score matching with a single difference. What happens in propensity score matching with a single difference? If I have been introduced at the end line, I don't have any baseline data at all. I just ask the respondents about their caste, religion, the number of earning members, all those kinds of covariates that we talked about. Right? Covariates are what? These are indicators that do not directly influence the outcome, but indirectly have a role to play. Right? Obviously I know the farmers that I've worked with, so they become the treated. The farmers that I have not worked with, or the areas that I have not worked with, become the control. I match these two groups based on their covariance, right? And these covariants must be their pre-intervention characteristics. What is pre-intervention characteristics? You can always ask them, no, before the starting of the program, what was the situation? The caste would not have changed. Maybe the age would have changed. The gender would have remained the same, right? The number of earning members might have changed. So you see what I'm trying to say. If you're talking about numbers, the numbers would have changed from the pre-intervention characteristics, but the entire effort is to ensure that both these groups were similar to begin with. Say in the year 2019 they were similar, so you will have to ask them about the characteristics in 2019, match them in 2019, and then look at what are the changes in 2023. Yeah. So there are different kinds of tools that you can use. So there is something called a nearest neighbor matching. Nearest neighbor matching. Then there is a radius matching, kernel matching. There are so many different kinds of matching that you can use. Okay, there's a 1:1 matching. There is 1:many matching, many:1 matching. Okay, so for example, many:1 matching is like, say, if I told you, we'll have to come up with a composite score based on the socio-demographic indicators and all those kinds of covariates for which the value has been created. Let's say for the 5 of you, there's only one match here in this group, so it's a many-to-1 match. Let's say for one of you, there are like 5 people who can be matched. So there's 1:many matching, right? So all these kinds of matching could be used. Kernel matching, radius matching, you specify a range that if you have a score of 50, the person who has a score of 49 to 51 should be matched to you, right? So that kind of thing happens. So there are very statistical ways in which you can actually go ahead for the matching process. Okay, right. Can we use an RDD in this kind of a situation? Regression discontinuity design, what did we need for an RDD? A cutoff point. We wanted a cutoff point. Can we use an RDD here? Can we use an RDD for this situation? Can we use an RDD? My point is, why would you use an RDD when you can use the other designs? Right. Okay, so when the other designs were not possible, probably you could have gone ahead with it. And please go ahead with an RDD only when the problem statement very clearly mentions that they have a cutoff in place. Otherwise, whatever cutoff that you come up with based on the index that you generate might not be replicated in the other areas. So that becomes a problem. You might not be able to generalize your findings for the other geographies. Okay, can we use an IV or a randomized promotion or an RP here? Instrumental variable. Again, the same point. Why would you use an IV when you can use the other designs? Right? Okay. I mean, you can use a randomized promotion here. Let's say if this app was open for all the farmers in a particular district, then it is a universal coverage for that particular district. Right? In that case, you will find these 3 individuals: never enroll, always enroll if promoted. You look into the changes what has happened in the enroll if promoted group, and that becomes your impact of the project. Okay? Oh, nice. This one. In the absence of a baseline, please design an evaluation of a 5-year long program aimed at improving the overall well-being of the households. So the overall well-being they have mentioned: physical well-being, economic well-being, social well-being, development and activity, emotional well-being, psychological well-being, life satisfaction, domain-specific satisfaction. You don't have a baseline. We just talked about it. I heard propensities in this. Right. That is absolutely right. So in the absence of a baseline, if you don't have a baseline, please think of a propensity score match. Right. So the clue lies in the first few words there. So in the absence of a baseline, think of a propensity score matching first. What happens if it is a 5-year long program? Go to the households. I mean, you already know about which are these project areas because you've been invited at the endline stage. So the project areas are already there. The first thing that you need to do is to come up with a comparison group. Then the comparison group would be like villages from the same block, but then you'll have to do a matching. So only the matched villages should be there. You go, once the villages have been mapped, you go ahead with a random sample for the households in each of these villages, get the data in place, and then you use a propensity score matching. That there will be sample loss from this group also, there will be sample loss from this group also. Then you compare their estimates, come up with a DID, a single difference, not a double difference, a single difference between the treatment and the control, and that will give you the project estimates. A collective of farmers that engages in producing and collectively selling the produce in the market is called farmer-producer organization. Okay, so there are several group of people farmers have come together. They're producing the same thing. They're selling the same thing. So basically, they're forming a farmer-producer organization. It's a registered entity. Okay, this organization is registered under some national act. Please design an evaluation to assess the performance of these FPOs in the last 3 years. What will you do here? So, an FPO is a company. It is registered under Companies Act. So, basically, we are talking about what is the outcome level indicator here for a company. Either their yields would have increased, or their profits would have gone up, or their revenues would have gone up. Let's talk money here, right? So, their revenues would have gone up, or their profits would have gone up. That is the outcome indicator. That is the evaluation question that we are looking to answer. It's a 3-year intervention. Do we get a sense here? At what stage have we been involved in? Has the baseline happened? Are we at the endline stage? Is there any ambiguity here? What is the sense that you get? Because in the last sentence it says very clearly, please assess the program of the last of these FPOs in the last 3 years. So I am at the endline stage. The guys have not conducted a baseline, right? What do I adopt? What do I adopt? What design do I adopt? We discussed this. We discussed an example just moments ago. PSM. It's a propensity score matching. The baseline is not there. Think of a propensity score matching. Right? Great. Case study number 4. A campaign was launched in certain geographies to improve awareness on climate change and clean air. For this, the AQI, this is the air quality index, AQI index, was displayed on large boards with certain key messages on damage to human health and the environment due to climate change and ways to contain or minimize it. Please design an evaluation to measure the impact of this program. What will we do? What is the intervention here? campaigns are being launched, right? What is the outcome indicator here? To improve the air quality, right? What can we do here? At what stage have we been included here? So it says the program was launched. I am assuming that we will involved at the endline stage, right? But at the endline stage, just think about the kind of project this is. This project is not a door-to-door campaign. It is basically you have left a message somewhere and people might read into it. Can anyone help me with this? What kind of a design can we propose here? Can we use an instrumental variable? Randomized promotion can be used. Let's think why can we or why can't we use an IV, an instrumental variable or a randomized promotion design? But then if it is a hoarding, then many people would be able to see it. It is a universal coverage, maybe in a certain geography also, but it does have a universal coverage. Sorry? Does not have any, sorry? Cutoff point. Cutoff point is required for an RDD. We're talking about instrumental variable, randomized promotion design. Right? Can we have people who will never enroll? Can we have people here who will always enroll? Can we have people who might enroll if promoted? But what are they enrolling into? What are they enrolling into? This is a very tricky case study. You can assume that they have enrolled into the group that has become aware of climate change or climate change mitigation strategies. It doesn't have to be a very specified group, but if they are made aware, probably that might also translate into adopting better mechanisms to contain climate change. This is a far-fetched. You will have to sit with the client on this, get an approval. Only then you go ahead with an IV or a randomized promotion, right? If you are able to convince everyone that this is the situation, then you go ahead with a randomized promotion. Otherwise, it's going to be very difficult. Is there a non-promoted group here? Is there a non-promoted group here? Because this message is available for everyone. Is there a non-promoted group here? Huh? Is an IV possible here? IV is not possible. We don't have a non-promoted group. IV is not possible. Right? So after thinking everything about IV, we finally come to the conclusion that one major group is missing, which is a non-promoted group. Even if we consider it to be a universal coverage, say for a particular geography, but still there is no non-promoted group. In that case, we have to drop the design. What is the other design that we can use here? Sorry? Non-expert. Perfect. That is the only design that is left now. So we can simply look maybe just get a sample of people and tell them, or just ask them whether they've seen this message. If they've seen this message, whether it has translated into a behavior change, have they adopted better climate mitigation strategies, right? So that is the kind of research that you can conduct. Obviously, you won't have a counterfactual there. You can still create a counterfactual there. People who have seen the message but still have not adopted the climate resilient practices. People who have seen the message and have adopted the climate resilient practices. People who have not seen the messages and have not adopted the practice. So you might have three groups here. You can still go ahead with an experimental design there, right? But it will be a quasi-experimental design, right? Good that we are thinking on these lines. Nice. Let's go to the next case study. So this is the last one. Okay, the last three case studies, and then we quickly wrap it up in the next 5 minutes. It is 1:56. By 2 p.m. we close. Okay, so long-term government program is being implemented in 3 phases to improve the water sanitation and hygiene status of the household. Phase 1 between 23-24, phase 2 24-26, phase 3 26-27. Please design an evaluation to measure the impact of the program. What is happening here? The clue is in the implementation. I hear step-wise. How many of us agree with step-wise design, pipeline design? All of us? Great. That's the answer. A long-term government program is being implemented in 3 phases to improve the learning outcomes of students in grade 5 using adaptive learning platforms. Phase 1, 2, 3, 4, 5. Please design an evaluation to measure the change in the learning outcomes of the students. Which design should we use? Which design should we use? Step-wise? Step-wise? Everyone in agreement? Okay, that's the right answer. This is the last one. A food distribution policy has been launched by the government in a national emergency situation. This is something that we have already discussed. Okay, so then we can break for lunch. Okay, we've covered everything about evaluations. The objective here was to not go too deep into the different kinds of evaluations. As I was mentioning, I can share a few evaluations with you after we come back from lunch, but after we've discussed the sampling, because that is one major component that is still remaining. For now, I think we have a good understanding of what are the different kinds of designs, and I am assuming that we also have developed some sense of, under what situations and what kind of situations can we adopt different kinds of designs. Okay, even if we've been able to get like 5% or 10% of that intelligence, I think that's good enough for this session. That's a good start. And if any of us is more interested in exploring this further, please feel free to reach out to me. I'll also leave my email ID and my contact number later, just in case if you would want to reach out to me.